I tend to believe that aging is more a byproduct of an absence of selection, where once you have done your job of reproducing and passing your genes on to the next generation, there's really not a lot of reason for natural selection to prevent aging. And I think intuitively that makes sense, and I think that lines up pretty well with most of the data that's out there on the genes that affect longevity. They don't appear to have evolved because they regulate longevity. They appear to have evolved because they regulate growth and reproduction. And I think things like mTOR and these nutrient sensing pathways are a really good example for understanding that. So mTOR is one of the better characterized longevity proteins or genes. And what mTOR does is fundamentally it senses the environment and helps the cell or organism make the decision whether it should grow and reproduce, or if the environment's not favorable for growth and reproduction, shut down growth and become stress resistant, right? Mm-hmm. It turns out that one of the key features in the environment that are really important in that decision-making process is food, right? Yep. There's not much food around, really bad idea to have babies because you don't have anything to feed them. So mTOR primarily senses nutrients. When there's lots of food around, mTOR gets turned up, that accelerates growth and reproduction, also accelerates aging. When there's not very much food around, mTOR gets shut down, that slows growth and reproduction and promotes a stress-resistant state. The delayed aging we see with turning mTOR down is probably a byproduct of that enhanced stress resistance. And people have speculated that that's because, again, from an evolutionary perspective, it makes sense to survive long enough until the environment changes and becomes favorable and there's food around. Yeah. So I think that's a really good example where it's pretty likely that mTOR evolved to regulate growth and reproduction, and it's kind of an accident that it regulates aging.